Hello, welcome to the fourth video in a series of videos on essentials for astrological research. We ended the previous video talking about multiple hypotheses and how we need to correct for multiple hypotheses. And at the end of that video, I said we would go on to the next topic, but now I realize there's a lot more I need to say about multiple hypotheses. So very quickly, let's review the basic idea. The basic idea is this. If you have just one idea of what is going to be in a group of charts, like let's take the example of people with ADHD, which is the scenario that one of the scenarios that we're using in this series of videos. And suppose you have an idea that people with ADHD were probably born with Moon and Uranus square each other. Okay, you've got one idea of what's in their charts. Is that what usually happens in astrology? No. Usually we have a lot of ideas. We're thinking Moon and Uranus, they might be square, they might be opposition, maybe Mercury, Uranus, or Mercury, Saturn in hard aspect. Maybe these planets are out of bounds, which if you're an astrologer, you're familiar with that idea. Declination is beyond 23 degrees, 27 minutes. Parallels of declination is another idea a lot of us use. Also, the zodiac sign. We think, wow, if Mars is in, its detriment or fall, that would be Libra or Taurus or Cancer. Then, Mars is not happy and things can go, can become difficult. So, we have typically a lot of ideas. Some of astrologers also use the idea of the ruler of the house of the planet of the house that the planet is in. So if Mars is in the third house in Gemini, then you look at Mercury, which rules the ruler of the house, and maybe Mercury is squared to that planet in the third house, or some other kind of configuration that's considered to disturb things. There are so many things. Some of us also look at particular fixed stars. Well, when you lay out this long list of possible things, some of them are going to happen purely by chance. It's very, very simple. Sometimes people who are not familiar with how these probabilities work, they think, okay, it's 1 in 100 probability, or 1 in 50, or 1 in 30. Very unlikely that you have Moon square Uranus. Very unlikely that you have Mercury square Uranus. Very unlikely. And they think that each one of those is independent of each other, but they're not. As you make your list longer, if you have 3 things, you've tripled the possibility that one of those will occur. If you have 10 things, it's 10 times likely. Sometimes we have 100 things. There's even research where astrologers have written articles, they've written books with an enormous number of expectations. In some cases, no expectations. They just run every possible thing through some kind of research software. Well, then if you run 100,000 different astrological things, you're easily going to get 1,000 astrological factors with a probability of less than 1 in 100. Okay, so you got the idea. You have to correct for multiple hypotheses. Now let's take a very simple example to show you how quickly it becomes likely that somebody has something. And this is not only an issue for like a formal research study, but just in thinking about astrology in general. Here's a typical example. Suppose you're interested in what is in the charts of singers. People have good singing voices. And maybe your thought is the sun, moon, or ascendant, the really 3 big things. Good chance they would be in Taurus, and maybe you think also Cancer. So you're thinking, wow, I bet singers have sun, moon, or ascendant in Taurus or Cancer. So you look at the chart of a famous singer, so maybe somebody that you like, and you go, wow, moon is in Taurus. Cool. Then you look at another one. Ooh, ascendant is in Cancer. You look at a third one. Also, another confirmation. Maybe, moon is in Taurus for the third one. And you're seeing repeatedly, wow, this really seems to work. And then you hit a few that don't work, but you don't expect everyone to work. If you can very easily feel like you're on track. But think about what the probability is. The probability that the sun is in Taurus, there are 12 signs, it's roughly 1 in 12. Now, it's not exactly 1/12 because people tend to be born at certain times of year, but roughly 1/12. So what's the probability that sun will be in Taurus or Cancer? That's 2 out of 12 signs, 1 in 6. Probability of moon in Taurus and Cancer, also about 1 in 6. Probability of ascendant being in Taurus or Cancer, about 1 out of 6. Although with rising signs, our estimate of 1 out of 6 could be pretty far off because different signs rise for longer and shorter periods of time. If most people in a lot of research are born in the northern hemisphere, and Pisces and Aries don't rise very long. Anyway, it's not actually a very good estimate, but let's say it's good enough for our purposes. So what's the probability that you'll have sun, moon, or ascendant in Taurus or Libra? It'll be 1/6 plus 1/6 plus 1/6. It'll be about half the people. So, it doesn't feel like it. Like, wow, about half the population is going to have Taurus or Cancer conspicuous in their charts. It's going to be the sun, moon, or ascendant. Yes, true for any sign. So even just in our casual thinking about astrology, sometimes things feel like they're more unusual than they are, just intuitively. Maybe for you that's not true. Maybe it is true. Anyway, I'm just pointing out how quickly different combinations of things add up. And pretty soon, you add a few more things, it's like everybody's going to have that in their charts. So, just to make sure your intuition about this is good, just realize how quickly the probability that you have something in your chart increases as you add more things to your list. Now, suppose you think that singers have sun or moon in or ascendant in Taurus or Cancer. There's nothing wrong with that. Maybe you also think they could be in parallel or out of bounds or conjunct fixed stars. Maybe that's your idea. Typically, we do have ideas like this, and there's nothing wrong with it. So here's a way to solve this problem that almost everybody's going to have these things. Instead of testing each one separately and giving the probability of each one separately, combine them together. Just combine them together. And we often call that an AstroSignature. And when you combine them together, give them however many points you want. So if you think that sun in Taurus or Cancer, or moon in Taurus or Cancer, or ascendant in Taurus or Cancer are all equally likely, give them some arbitrary number like 10 points. But if you think moon in Taurus is way more likely to have a good singing voice, you can give it more points. Give it 15 points. Or if you think it's twice as powerful, give it 20 points. Just give it some rough estimate of how important each of these are. And you can add as many things as you want. Add parallels of declination, add out of bounds, add planets conjunct fixed stars. You can put all of those things into an AstroSignature in the Sirius software. It's right there in the AstroSignature feature. You just add these things in. I've got here at the bottom, by the way, 2 excellent videos on learning how to use the AstroSignature Research feature in the Sirius software. One of them is called the AstroSignature Research feature in the Kepler and Sirius software, and the other one's called Advanced AstroSignature Research features of Kepler and Sirius. So those two videos are going to give you. I won't, because I've already got these videos done. I'm not going to repeat that here. So you can just watch those other videos if you want to see step by step how to do this. So, but for our purposes in this video, just know that you can do it. It's pretty simple. You just make the list and give however many points you want to it. Then you just run that AstroSignature for your singers and see what their scores are. Maybe they'll average, 23.7 or something, or whatever that comes out to be. Their average score. You'll just get that list and you can save that. You just click on the button to save it, and it saves the results for each person, each singer, and it'll show you what the average score is. So you can just run that, and then you can run it for some other group, maybe scientists, whatever, maybe baseball players. I don't know, some other group. You can save that to file, and then there's a test, a statistical test. It's called a t-test. It's included right in the series software. You don't have to go outside the program. You don't have to do it. It's right there. You just tell it to compare the two groups. It'll compare them, and it'll tell you what the probability is that of the scores being different from each other. So suppose the average score for singers is 25, and the average score for scientists is 22. Well, is 25 versus 22 a big difference, a small difference? I don't know. It's also not just the average score that determines the likelihood of those differences. There's a whole distribution of the scores. You just run this test and it tells you the likelihood of that is less than 0.05, less than 5 out of 100, or less than 5%, or less than 0.01. It'll just tell you. And that will give you a very good idea. So the easy way to overcome this problem of multiple factors is to use the AstroSignature. There, very simple. Because it's combined them together all into one thing, and then you're seeing how your total set of astrological variables is working. So, these people that have written articles and they've written books saying, the likelihood that Moon was in Taurus for these singers is less than 1 out of 10,000, and the likelihood of this, you can put all those things into one AstroSignature, compare two groups, and now you've got a realistic assessment of whether the singers that you're studying really have that in their charts. Okay, so that's just to make it clear, because otherwise you might think, gee, it's complicated to get around this problem, and maybe I shouldn't have so many hypotheses. No problem. Just put them all into an AstroSignature. Now, there's something else I want to mention about this, and another big reason why I realize I need to make this video is because in none of the other places in this series do I bring this up, and it's really, really important. Suppose the singers have a higher score on these things that you think give a person a good voice, give them singing ability. They have a much higher score than scientists. And suppose they have a much higher score than baseball players or basketball players or what have you. And so you go, wow, I've compared the singers to these other professional groups, and I ran the t-test, and I got P is less than 0.01. It's very clear that the singers do have these things in their charts. Well, that's good. That is good evidence. There's something even better you can do that will give us even more confidence. Remember, what we're looking for is confidence in our theory. We can get more confidence, and this is what it is. Instead of comparing singers to scientists, or singers to baseball players, or singers to whatever, politicians, any other group, what you can do is compare singers to what we call a shuffled control group, is a term a lot of us are using for this. A shuffled control group. This is an idea I found out about, I don't know, maybe 15 years ago or so, I don't remember. And when I heard this idea, I went, OMG, this is fantastic. Just marvelous. It's a simple idea. And all it is this. You mix up the date, times, and places. So suppose I have one person born on January 1st at 12 noon, and another person born on July 1st at 6 p.m., I swap the dates and times. So instead of person A born January 1st at 12 noon, I say they're born January 1st at 6 p.m. I swap the places. So I take the date, time, and place, and I shuffle them. You can imagine just like shuffling a deck of cards. So I mix together, say, my birth date with your birth time and someone else's birthplace. You mix them all together. And this is a fantastic control group, because what it means is that this shuffled group is going to be born during the same years as the singers, right? Because I've used the same years. They're going to be born in the same places, and they're going to be born at the same times. They're just all mixed together. So it is a wonderful control group, because you don't have to worry about comparing. If I compare singers to scientists, maybe the singers are born in different places. Maybe they tend to be younger. Maybe the planets moved into different configurations at different years. I don't really know if what I'm looking at is a difference in the times the people were born, or is it a real difference? I may be, based on the situation, I may be able to get a good guess, but a shuffled control group is really, really wonderful. And we call it a conservative estimate. So I've got here in the bottom of the second paragraph that the results that we would get by comparing the singers with a shuffled control group of singers gives us a conservative control group and gives us a conservative estimate of probability. Conservative means, in research and statistics, in this context, means that if you get good results, like if you compare the singers to the shuffled control group of singers on their AstroSignature scores, and you run this t-test, you can, and by the way, you do all of this right in a series software. You make the AstroSignature, you run it for your singers, you make the shuffled control group, the features right there in the software, you compare it, and you run the t-test, all right there. So you don't have to learn some other statistical software or anything. And if you get, for example, p less than 0.01, less than a 1% probability that the singers would have this combination of things in their charts compared to the shuffled control group, that is a conservative estimate, because the control group is unrealistically similar to the singers. In real life, it can never be that extremely similar. So if you get a good probability comparing to shuffled control group, you have good confidence that you really found something. It's better to be conservative so that you're more sure that you're really finding something. And especially in astrology, where we're trying to validate something that has really never been validated ever for thousands of years. I've got videos I've made about the Galco research and other things showing it's impressive, it's promising, but it's in no way convincing. No. So we're trying to make a breakthrough here. So it's good to be conservative. Now let me just show you quickly how you make the shuffled control group. You go over here to the research feature, this little purple icon that looks like a magnifying lens with the glyphs of Jupiter and Saturn, and select, there it is, make data for stat software or control group. So this, you can export data that you're going to put into a statistical program or something, or make a control group. This is what I want. And then it comes up with 4 choices, and select the bottom menu item, create control group, and put in a my category in the Sirius database. So I select this, and here you select the charts, select category of birth data. So I'll click this, and suppose I want to take the singers. So I would click on here, musicians, and select singer. Okay. So now I've selected singers. Now I want to select a category that will be the shuffled group of singers. So we're going to shuffle their date, time, and place, just like shuffling cards, and give them their own category. So select the category for the control group, and again I'm here, and put it in a My Data. And let me show you a little trick. You can check this box, Show Number of Charts. What this does is, as I select something, I'll make sure there's already no charts in this. So I'm going to take my category number 18, it tells me that number of charts in this category, 0. It's confirming. I didn't already put some charts in there, and I'll rename it. I'll call it Singers Shuffled Control Group. You know, I'll just put CTRL GRP, whatever you want to call it. So, and I'll click on Update. Now I click OK, and I'm going to put the control group, this shuffled control group. All I have to do is click on Create the Control Group. I'm not going to do it because it takes a little while. Boom, it will do it. And then I can run my AstroSignature, the list of things that I think inclines a person to be a singer. I can run it for the singers and run it for the shuffled control group, and then I can click on the button to compare them, the t-test. In fact, I believe, let me check something here. I'm not sure. Yeah, it's right here. When you go into the AstroSignature feature, it's right here, t-test. See this little button, t-test? And when you click on t-test, it'll show you the files, the results that you've saved. So you run the analysis, you save it to file, you just click on the button to run it and to save it, and you give it a name, and then you select them, and then you click on compare data and calculate statistics. That's all there is to it. And then it will show you what the probability is. And it'll show you some other things like the average score, etc. And that's it. If that probability is very low, it's looking like you've discovered something. You're verifying. So this is how not only do we control for multiple factors by making an AstroSignature, we're also seeing clearly the likelihood that our formula works. All very convenient, all very nicely done, and it's just beautiful because you're really going to get professional, like academically sophisticated results just by clicking these buttons. So this is how you correct for multiple hypotheses. It's one way. There are other ways, but make an AstroSignature, make a shuffled control group, compare. Now you really know if your model, in other words, in this case for AstroSignature, is really working with the data you have. And if it is, the next step would be to get more data, collect some new data, or find another source of data, test it again. And if it works again, wow. Now you've got something very, very exciting. Okay, and so that's like a normal process for doing things. Now, let me just mention a few more little things here, just because these things might come up. These are not things that you should be doing. But if you hear about somebody running each individual astrological predictor separately, so they look to see if Moon square Uranus shows up more for people with ADHD, or Mercury square Uranus, and they do each one of these individually, and then they show you what the p-values are for each one, and they will look impressive, because the more things you have in your list, the better the p-values are. And they might have a book or an article, and they'll say, oh, look, there's 100 astrological factors for ADHD or whatever it is they're studying with a p-value less than 0.001, which is a fantastic p-value. Means less than 1 out of 1,000. Or it might be less than 1 out of 10,000 or 100,000. The more things you test, the more impressive the p-values will be by chance. Now, just to let you know, if you're looking at something like that, because you might say, well, David said, they've tested a lot of things, but hey, give me a break. 1 out of 10,000, 1 out of 100,000. So just to let you know, if you want to know how good that result is, there's a very simple way to do it. You take the number of things, the number of hypotheses, the number of of astrological predictor variables. So say each one individually. Moon square Uranus would be one. Moon opposition Uranus is another. Whatever list they produce, you take their list. How many things did they check? I've seen research where they've checked like thousands. And then divide the p-value obtained. Like if the p-value is 0.001, and then divide that by the number of hypotheses. So if you get a p-value of 0.05 and you have 100 hypotheses, the actual p-value is 100 times worse. So for each additional hypothesis you have, it makes your actual real p-value that many times worse. So if you have 100 hypotheses, your p-value is actually 100 times worse than you thought it was. And in order to get a 0.05, you have to get a 0.0005. 100 times smaller is actually equal to 0.05. Okay? If you didn't follow that, maybe I didn't explain it very clearly. All I'm saying is that if you get a p-value less than 0.0005 with 100 hypotheses, you have to multiply this by 100 and you get 0.05. It's actually only an 0.05 probability in reality. So if you have 100 hypotheses and you get a 0.0005, then that's fairly good. It is in reality less than 0.05. So that's, the actual real hypothesis. This is the actual real probability. I'm sorry. That's the actual real probability. You have to multiply by how many hypotheses you have. This is called the Bonferroni Correction. Okay, the Bonferroni Correction. Bonferroni. So that's the Bonferroni Correction. Okay, so there it is. Anyway, just thought I'd let you know, because people do publish these kind of things, and all you have to do is apply the Bonferroni Correction. And if you're not comfortable with numbers, you can just say to somebody, what would this be if we apply the Bonferroni Correction? You can always go to somebody who's trained in statistics and research methods, and you know what to ask. You know what the problems are. You know what to look for. You don't have to be the number cruncher, but to know what the issues are is something that anybody trying to figure out how astrology works by doing some kind of research, these are simple ideas. All I'm saying is you have a lot of hypotheses. You can't just use those p-values. You have to correct them. And there's something called a Bonferroni Correction. If you don't like all these numbers and they make your head spin, just have somebody calculate it for you. It's very, very simple. Or confirm how to calculate for that particular situation. Very, very simple. Okay, so I wanted to let you know about these details of multiple hypotheses. And one more thing. I think this is my last slide. Yes, it is. This is my last slide on multiple hypotheses for this video. One more thing. This idea of AstroSignatures is really, really, totally awesomely cool. And it's also an idea that's used in genetics research. I mentioned that in one of the other videos. They use the same idea. You combine together all the individual markers, the genetic markers for some condition, and you assemble them all together. And in one article I read about the genetics research, the genetics researcher states that each one of these genetic markers, they have like a negligible effect. I mean, in themselves, they're not doing anything. But when you combine 20, 30, 50, 100 of them together, you're seeing a noticeable effect. So say for obesity, let's say there's 100 genes that are inclining towards obesity, regardless of anything else, just your genetics alone. Each one of those genes may contribute almost nothing, but you combine them together and you're starting to see, you will see, some effect on obesity. So it's the same thing in astrology. You don't have to feel bad if you've combined together 30 or 40 things that are only slightly inclining a person to be a great singer. They're doing it in genetics. They're getting paid to do this research. People are using these ideas. Nothing wrong with that. So we're using an idea that's established, that's successful in standard academia, that's making exciting breakthroughs. Same idea. So not only do we correct for multiple hypotheses, but we're using a really an excellent approach to developing these ideas. And we have also gotten some of our most exciting research is simply AstroSignatures. One of the most exciting is the bipolar disorder research by Giselle Terry and myself. Right now it's available only as a recording from lectures in the Vibrational Astrology Conference lectures that you can purchase. And we are going to be making that information available about the bipolar disorder research through other means. We're working on it, writing it all up and making it it'll be available in other ways at some point, maybe by the year 2022 or so. We'll get this information out because we need to make it available to people. It's exciting that we build these AstroSignatures and they appear to work, and we replicate with small data sets that we're able to collect and get very positive indications. So anyway, this is all part of dealing for multiple hypotheses. And as we know in astrology, we don't look at one thing. I mean, obviously, we don't say, oh, your moon is in Taurus, you're a great singer. We're looking at a complex combination of things. And the AstroSignature enables us to do that beautifully, elegantly, validate it, test it, and there's clever ways to improve it. And one is looking at the extreme cases. So, you can take the singer, for example, whose voice is just out of this world. I mean, there's all kinds of, in the Sirius database, there's over 1,400 singers. Well, some, they're all professional singers, but oh my God, I mean, some of them have voices that are unbelievable, or certain kinds of voices. And then you can study those individually. And this is the extreme cases, and then get ideas from that, and then adjust your formula based on that. So there's so many ways to build and improve our models and to validate them and to see them work, and tremendous progress is being done in this. And in astrology, we have multiple things involved, and it's not a problem. It works beautifully using these research methods. So last thing I want to mention here at the bottom of this slide, that when you're combining variables, here's one last point. Typically, you're doing it based on your approach to astrology. Maybe you use medieval astrology ideas, or Vedic astrology ideas, or Hellenistic, or I use vibrational. You're using the ideas that you think work, and you're building your AstroSignature based on your expertise. Now, but let me mention this possibility. What if you are a Hellenistic astrologer and you find things that incline to bipolar disorder? And then suppose a Vedic astrologer finds some things inclined to bipolar disorder, and it's completely different. I mean, it's just like, they're using nakshatras and, Navamsa chart. I mean, just like, whoa, totally different ideas. And then maybe we come in with vibrational astrology, totally different from the other two. Could we bring those different models together, like this Hellenistic model that, is based on maybe essential dignities and what we call sect, where you're born at day or night, and you have Vedic, which are a completely different set of variables, and vibrational astrology, a completely different set. What if different astrological systems all work, or some of them work, using different sets of rules? No problem. Very exciting. You can just combine them together into an AstroSignature. Why not? You can have an AstroSignature based on Vedic astrology, another one based on Hellenistic, another one based on vibrational astrology. Combine them all together into one large AstroSignature. And you know what will happen if they work individually? When you combine them together, they work tremendously better. Your p-values, probability values, when you compare the group you're analyzing with the shuffled control group, the p-values, boom, they get tremendously better. So you can combine the things that you think are important, and if somebody else finds something else, you can combine it together. And in fact, we have a case where this happened, which is the Galcoin research, where I have two videos, and one of them is called "Did Galcoin Improve Astrology Part 1?" and the other is "Did Galcoin Improve Astrology Part 2?" And they are the Part 2 of it combines together Galcoin's idea of plus zones. It combines Galcoin's findings with the findings from vibrational astrology, and then you get really, really impressive results. So anyway, I just thought I'd let you know that there's so many exciting things that are possible, and I'm sure will be happening in the future. And of course, links to those two videos on the Galcoin research is in the description for this video, so you can easily access those if you want to. Okay, my friends, that's the end of the fourth video in the series of videos on essentials for astrology research. Thank you very much for being a part of this. God bless. Namaste.